When trying to improve our usage or management of data, we often want to leverage metadata, but metadata is a really broad term that covers all sorts of different categories of data about data. So let's draw a map to help us. Basics first. Structural metadata describes the fields and data types in our datasets. We often already have this because it's right there in our schema definitions, but we can still benefit from making it more visible. By giving analysts the way to see this kind of metadata around datasets that they don't already have access to, that gives them a way to figure out if that dataset might be useful to them before embarking on the access process. Serving this kind of metadata is one of the most common features of metadata cataloging tools, but can be a really quick win to show and prove the value of those tools when introducing them for the first time. Once we have somewhere to serve this metadata, we can start to layer richer metadata on top of it. Semantic metadata relates data fields to important concepts in our business or domain, using data dictionaries or taxonomies. We can also classify data, for example, flagging fields that contain personally identifiable or other sensitive information. Semantics always have nuance to them and require human judgment to get right, but automated tools are becoming better all the time and can be particularly useful for things like finding sensitive data in a field that it shouldn't be stored in, where a human might not even think to look to check for it. Statistical metadata tells us about the shape and contents of our dataset. It can be straightforward to generate automatically, but unlocks value from human insight in interpreting it. Things like ranges on numeric fields, the proportion of null values, or histograms of common values can help understand things like demographic coverage or quality of the data. Upstream metadata tells us where our data comes from and how we can use it. For example, who owns the data, any data sharing agreement under which it's provided, our legal basis for processing it, and any restrictions or expirations on those. We usually think about this as being relevant for governance, but it can also be really practical. For example, how often a dataset is updated or the process for obtaining it. That can be useful not only to our analysts who work with the data, but also to our technical teams responsible for managing it. Those technical teams will also need various supporting metadata. So how and where the data is stored, backup and continuity processors, or archive and disposal policies, as well as the size and growth rate of the data. All of these are important for enabling those teams to do their job of supporting our use of the data. And they're probably already maintaining it somewhere, but it's still worth formalizing and improving the visibility of. This kind of metadata is how we know we don't have a business-critical system running on a laptop underneath someone's desk somewhere. Finally, we have usage metadata. This includes governance information, such as the access process for different datasets and a record of approved users. But there's a lot more to it than just controlling access to data. Knowing how often different datasets are accessed allows us to focus our time and effort on the data that's most useful to our organization. We can go further by modeling lineage through to our own data outputs, giving us further insight into the value of different data sources. Also, knowing the regular users of different datasets allows us to encourage knowledge sharing within our organization by identifying experts who can help other analysts to get up to speed and make the best use of the data we have. In summary, we can have more useful conversations about metadata if we consider what kinds of metadata we need, how we can collect and maintain accurate metadata, and who's using that metadata and for what purpose.